Welcome and hello. This is a support video in HEC RAS, and I titled this video Building a Simple 1D Reach with Cross Sections. All right, so this is actually a response video to some of the questions or comments that I've been receiving in my HEC RAS lesson number 4, specifically, how did I make the geometry file? How did I get the starting cross sections at river stations 1500, 1000, and so on? So this video is sort of a response video to answer that question. In a lot of my videos, there's sometimes gaps and overlaps of knowledge. Sometimes I repeat things, and other times I may actually leave some critical information out. So this support video is to assist those who are interested in learning how to build a simple 1D reach with cross sections, which is apparently information I left out of my lesson 4. I'm going to go ahead and link my lesson 4 and also my lesson 3, which gives an overview of geometric data, in the video description. So go ahead and check those out. All right, so let's get started finally. We have our main HEC RAS interface, and then down below here I have my geometric data editor. You can open that up by going up to Edit Geometric Data, or by clicking on this button right here, Geometric Data. All right, so to sketch a reach, what you're going to want to do is click on this River Reach button right here, and then start with a single left click where you want to start the upstream end of your reach. And then just go ahead and make a number of different clicks at each of the vertex points. And then to finalize and terminate the reach at the downstream end, just go ahead and double click. Next, you're prompted to enter the river name and the reach name. So we'll call this River A and Reach 1. Okay. It's going to be just one river and one reach. We're not going to do anything complicated here. When you're done sketching your reach, you can just click the River Reach button again to unselect it, and then you're back to your normal mouse cursor. All right, let's go ahead and add some cross sections now. To do that, click on the cross section button over here to the left, and then it brings up this cross section data editor. And what we want to do to add a cross section, come up to Options and click on Add New Cross Section. So it's going to be adding a cross section to the selected river and reach with a river station that we're going to provide. So Options, Add New Cross Section. Here it's asking for the cross section river station. So this is the upstream end. Down here is the downstream end. I'm going to just start with 0 as the river station that represents the downstream end of my reach. So we'll type in 0 here, click OK, and then now it's up to me to provide the additional information to define that cross section. Again, this is going to be at the downstream end of the reach. We'll see the main plan view update with the cross sections once we save and close the data in the cross section data editor, but not quite yet. Let's just go ahead and start entering the data. So we have our river, we have our reach, we have the cross section number. It's the only cross section we have. This is the river station. And then we have a description that's optional. And then we have station and elevation data to define that cross section. So let's go ahead and start typing this data in. The station data is going to be increasing. And this is going to be as if you're facing in the downstream direction. And the stationing is going to go from left to right. So typically I just start with 0. And then the next station would be, say, 10 feet over. I'm in US customary units, as it says right here. But if you're in metric units, then it'd be in units of meters. All right, so the third station I'll say is 30. And then as I'm typing in the station, I can also put in the elevation data, which you probably would want to do at the same time. So again, I'm just making up numbers here. I'm going to say 85 is the elevation, and then 10 feet over, the elevation is 60, which is an absurdly steep slope. But again, I'm just making up these numbers. And then 30 feet over in the cross section, I'll say that the elevation is still 60. So that would be 20 feet of a flat area here, just an embankment right there. 20 feet is 30 minus 10, 60 minus 60 is no change in elevation. All right, I'm going to continue by typing in the numbers here, just manually. 90, 60, and then finally 100 feet is the total width of the cross section. That last cross section point, it has an elevation of 85 feet. So there are my numbers for my first cross section that is at River Station 0. If I want to see a preview of this cross section over here in the side panel, go ahead and click on this button, Apply Data. And then boom, here is my preview. We have sort of a main channel and then a left and right overbank. So I drew it out that way on purpose, just to sort of be explicit, just to show the 3 different parts of the cross section. If you don't see this side panel over here that gives you the preview, you can toggle that on and off. So it might just be toggled off. That's this little button right here. That for the downstream reach length, since this is a cross section at the very bottom of the reach, river station 0, I'm just going to type in 0 for left overbank, channel, and right overbank. But once we have another cross section that's further upstream from this cross section at river station 0, we're going to have a positive number here representing the distance from that cross section to the next downstream cross section. We'll address that a little bit later once we add our second cross section. All right, so for Manning's n value, this is the roughness coefficient. I'm just going to type in some numbers here. So 0.05 or 0.035. Typically, it's a little bit lower in the main channel due to more regular flow, more erosion, and more smoothness. All right, and then the bank station, what it's asking for here is which values in this left column for station represent the top of bank. Again, this is the left side, this is the left bank, the left overbank main channel, and right overbank. So what it's looking for in this left bank value is this station number associated with this bank point. So if I trace that down, I can just tell that's the station 30, and then the right bank point is going to be my station 70. So for left bank, I'll type 30, tab over, 70, and then tab over. Okay, I'm going to just assume that the expansion contraction coefficients, which are my default values, are fine. And then I'll go ahead and save, which will turn the text from red back to black. So apply data, it saves it. Boom, that looks good. And now we have the red bank station dots identified in red dots right here. That is at station 30 and 70. And then we also have the Manning's roughness coefficients identified along the top, which use the bank stations. So the left overbank is from 0 to 30. The main channel of 0.035 roughness is from cross-section station 30 to 70. And then finally, the right overbank is from cross-section station 70 to, what is that, 100. So there's two different stationings going on here as well, which I should probably point out. There's the main river stationing, which is associated with this 0 right here. This entire cross section is taking place at the downstream end of our river reach. And then this stationing right here refers to the cross section stationing, which is the stationing you're seeing in this plot right here from left to right, from 0 feet up to 100 feet. Okay, so we're done with our first cross section. What we're going to do next is add a second cross section 500 feet upstream from the first cross section. So what I'm going to do is click on Options, Add New Cross Section, and then boom, now it's asking me to specify the river station along this river reach for that new cross section. And I'm going to say 500, click OK. And now we have two different options. We have our original cross-section data right here at River Station 0, which we're already done with. And now we have our new cross-section at River Station 500, which we still need to define the data for. It looks like it copied over the existing Manning's n coefficient, so that's convenient for us. And there are a few other ways to make this cross-section data editor a little bit quicker. So I'm going to demonstrate that right now and also in the next couple cross sections. First of all, we don't have to manually type in the station elevation data. As you may notice, this kind of feels like a spreadsheet. So what I'm going to do is just bring over my master data. This is River Station 0 elevations for the cross-section stations. We've already done that. Here is the data we're going to be entering right now for River Station 500. And I have two other cross sections planned for a little bit later in the lesson. So anyway, I've actually copied these two columns over here so I can just highlight them together. Click on Control C. This is Microsoft Excel. And then come over here to my station elevation data associated with the cross section at River Station 500. And then you need to highlight at least or more of the cells that you plan to paste in. And then click on Control V. Boom, there are my numbers. And if I click on Apply Data, there is the cross section associated with these values right here. Now, you may or may not have noticed, but we do have higher values here. It looks like the elevation increased by 5 feet from the downstream cross-section elevation values. So 5 feet divided by 500-foot run means we have a 1% slope. The distance downstream from cross-section 500 to 0 is 500. So I'm just going to type in 500 right here for the distance downstream. This would represent a completely straight reach. And although that's not true, if we actually had a little bit of a bend in either direction, we may have a slightly larger or smaller numbers for the distance on the left overbank and the right overbank. But to keep things simple, I'm just going to say it's 500 for all three of these lengths. All right. We also need to specify the left and right bank station. This is again going to be 30 and 70. So let me type those in, 30 and 70. And with those bank station values, it now knows Manning's roughness coefficient is not 0.05 for the entire cross section, but rather 0.05 and 0.035. So if I click apply data, boom, we see that updates and the bank stations are now showing with the red dots. Okay, so let's add two more cross sections. I swear this will be a lot quicker because what I'm going to do is start with this selected cross section at River Station 500, click on options, and then click on copy the current cross section. Now what I want to do is select the river, select the reach. That's all done. This is going to be another 500 feet upstream. So I'll say 1000 right here, click on OK. All right. So now everything copied. This is now an identical cross section as what I have at River Station 500. But the only change I need to make now is change the elevation. And what I'm going to do is add 3 feet, which I could do manually by typing in 93, 68, 68, 33. But a faster way to do it is just to go up to options, adjust elevation, and then type in 3, or you can type in -3 or whatever, probably a positive number if you're adding a cross section further upstream. So I click OK. Those numbers have updated. I still need to save, so click on apply data. And then let's do one more further upstream, which would be at River Station 1500. Copy the current cross section. So River Station 1500, click OK, and then options, adjust elevation. This time, let's go ahead and just add 2 feet and OK, and apply data. In fact, let's go ahead and update the map by closing this cross-section data editor. We see our cross-sections have appeared. There's 500 feet between each of these cross-sections we defined in the plan view. That's probably a little bit too much. Oftentimes you want cross-sections a little bit closer than that, but for this it's fine. And then if we want to check out the profile of this river reach so we can see the elevation change between each of these cross sections, go back to the cross section data editor, click on plot, and then click on plot profile. Here we see at River Station 1500, we have the highest elevation. This is referring to the invert or the lowest elevation in the cross section right here, not the overbank. So we have at 1500 River Station, the invert is 35, and then down at River Station 1000, there's another cross section, its invert is 33, and then at River Station 500, this dot represents that cross section, its invert is 30, and finally the very first cross section we defined right here at River Station 0 as an invert of 25. Okay. So from this view, you can change the cross section if you need to edit it. Say, for instance, some of the data is wrong. You can go ahead and make changes, and you can switch between cross sections by using this drop down here or by using the up and down arrows. As you notice, as the numbers change with different cross sections, that specific cross section is highlighted on the plan view over here in the main geometric data editor with the magenta coloring. Okay, so that's how that works. So I'm going to go ahead and close that up. Make sure to save your geometry, file, save geometry data. I'll just call this base, click OK. That geometry file and title have been saved up here in my main file GUI of HEC RAS. And I hope this video was helpful to hopefully answer some of the questions that were posed to me in the comment section of HEC RAS Lesson 4, such as how did I make the geometry file? How did I create these cross sections? Now that you have cross sections, you can go ahead and build from there if you want to add bridges, inline structures, lateral structures, anything else.